Hi, and welcome to exercise 3 of topic 3, which is just using the ideas of assignment 1 and 2, as you will see. Again, we need to ask for inputs until a 0 is entered, and then all of these numbers we have to use to calculate the average of the numbers. So print the average of these non-zero inputs with 3 digits after the decimal point. The 3 digits after the decimal point we can take care of with toFixed, we know that. And the program should also print no data if the first input was a 0 to start with. So if we don't have any input and we get a 0 right away, then we have to just print no data. Let's tackle the no data as an exception and go for the happy path first, as always. I'm going to just grab the solution to the earlier exercise where we had a sum of numbers, right? So this makes the sum of numbers. And the average is, of course, if we look at the definition of average, that's the sum of the numbers divided by the count. Okay? And you might say now, well, okay, this is good because I already have in exercise 1 the sum being calculated, as we see here. So we start a sum at 0, while the number we get, and we read the first number here, while it's not 0, we add the number to the sum, we read in the next number, and so on, as long as this number is not 0. As soon as it's 0, we just go out of the loop, we jump out of the loop, and we print the sum with 1 digit after the decimal point. Well, let me collapse this a little bit. What's to do here? You could say, oh, I have the other exercise as well, where in assignment 2, we basically did nothing more than increasing the count. So I needed a count. Let the count be 0. Okay. You could say, well, we already have a number, right? So why 0? Why not 1? Because I already read a number. Okay. Well, it's in the name of the variable, of course, because what are we counting? I want to count the non-zero numbers. Okay. So you could change this to count processed numbers, okay, or count non-zero numbers. And you only know this after you check the number. So in this, with this name, count number of non-zero numbers, or count of non-zero numbers, I could do count of non-zero numbers, then the 0 makes sense, because I don't know what the first number is. I don't know if it's a non-zero number, so I still have 0 because votes are not in yet, okay? And then I can, of course, say if the number is not 0, then I will pass the test in a while, and then I can say the processing will be adding the number to the sum and also remembering that I had a non-zero number. So I'm counting the numbers and I'm adding them to one big sum. And basically this is adding the body of the 2 loops we had in exercise 1 and exercise 2, adding the bodies all at once in one loop. So this was the body of the first exercise, this is the body of the second exercise. Third exercise just gives me the same old loop with 3 and 2, exercise 3 and 2, their body together, okay? And I have to fix this to 3 digits, and I have to still take care of the no data case, but let's first see if we get somewhere already. Yes, okay. So this is, of course, if we immediately give 0, we expect no data, and he gives us, of course, 0 because the sum is initially 0. And with multiple data points, the output should compute to average So this is also something that's strange. We should check this case as well. First, let's take care of the no data. How do we know? Because that's what we're going to do. We're either going to write this. Oh, by the way, I know the solution to this problem. I'm still printing the sum, and I have to print the average. So let's calculate the average. Okay. That's the danger of copying code. Okay, that you start changing it, but you don't change it completely. So this is a problem. I need to change the to print the average. Okay, and the average will be, of course, what I calculate, how I calculate it. So let the average, and I can make a constant of this. Let's have a constant average that is the sum divided by the count of non-zero numbers. Okay. You could also say sum of non-zero numbers if you want. Okay, I'm going to leave it at that. So I expect one more test to run. Yes, okay, so this one is also done. But now the no data case gives me a problem. And actually now it's not a number. Why? Well, probably because if I give a 0 from the beginning, this loop is going to be skipped, and what he calculates is sum being 0 divided by count of non-zero numbers, which is 0. So a division by 0 gives you not a number for sure. Okay, so that's why I need to check if I have a problem, and either I'm going to do that or I'm going to print no data, right? Like this. And well, we can say this is going to be the if, right? And this is going to be the else. I can add brackets, but I don't have to because there's only one statement. Okay, but let's do it anyway. There we go. And this is what I need. Now, how do I know that I have actual data? You could say, well, if the sum is 0, right? Except for the fact that you cannot use equality checks in floating point numbers. This would be wrong for another reason, because if I enter data, actual data, that happens to be giving me a sum of 0, this would be wrong. For instance, if I give it 1.2 and minus 1.2, sum would be 0, but that doesn't mean I didn't have been given data, because I would have a sum of 0 and a count of 2. 0 divided by 2 would give me 0, an average of 0 for the two numbers 1.2 and minus 1.2. Okay, so this is clearly not okay. If we have a good tests, this should show. Okay, and indeed you have a lot of problems now. Okay, so what else is there to check? If I can't check the sum, I can't check the average as well, because I still have to calculate it, right? So the only thing I can now check is the count of non-zero numbers. And if this is not 0, or you could say bigger than 0, then I must have got numbers and I can do the calculation safely. And this is actually what gives me 4 green tests. And this is how I can finish exercise 3 of topic 3.